This video introduces the method of differences. It is the next stage of the summations that you met in Core Pure Year 1 and is a way of summing finite series where we've got a difference of similar terms. Okay, so the first part of a question is often to write the required terms in the required form. All right, what we have to have is a minus sign so that we have a difference. So we might have an expression that looks like this, or indeed there could be an expression with a gap between the terms. Once we have an expression that involves a difference, we are then able to follow the method of differences to arrive at the answer. So let's have a look at question 1, which introduces the method, and then we will look at some more complex ones in subsequent videos. So question 1, we're being asked to show that 4r³ can be written as a difference. Okay, so in this case I'm going to start with my right hand side and show that it is equivalent to the left hand side. So my right hand side is r², r plus 1 all squared minus r minus 1 squared all squared. Expanding, and then bring the r squared out the front. That gives us r squared plus 2r plus 1 minus r squared plus 2r minus 1. Simplifying, that gives me r squared, and the bracket, the terms cancel and leave me with 4r, which if I multiply out gives me 4r³, which is my left hand side. So I have shown that 4r³ is equal to this difference. We're then asked to go on and prove by the use of method of differences that the summation for r³ is this expression here. So using my workings from part A, we're wanting to show the summation for r³. We've got an expression for 4r³. So 4r³ is going to be equal to r equals 1 to n. The summation of the difference. So we've got r equals 1 to n again, and we need r squared, r plus 1 squared, minus r minus 1 squared, r squared. So now I'm going to work with the difference by the method of differences. And what I'm going to do is I'm going to consider the terms from r equals 1 up to n. I'm not going to write them all out, but I need to write sufficient so that I have a suitable proof and so that I can see the terms, so that I can see which terms I'm left with so that I can summarize. So this summation here will be, subbing in r equals 1, I will get 1 squared, 2 squared, minus 0 squared, and 1 squared. So that's when I subbed in r equals 1. Let's then put in r equals 2. That's going to give me 2 squared and 3 squared minus 1 squared and 2 squared. Now, strictly speaking, I'm adding the terms together. Let's do r equals 3. So we get 3 squared and 4 squared minus 2 squared and 3 squared. So you can start to see that we are starting to get 1 or 2 terms repeating. And that is the power of the method, because it will allow me to do some cancellations. Now, I obviously can't write them all out, so I am going to jump to the end of the series, and I'm going to consider r as n minus 1 and r as n. So for n minus 1, that's going to give me n minus 1 squared, n squared, minus n minus 2 squared and n minus 1 squared. Okay, and last but not least, we get n squared, n plus 1 squared minus n minus 1 squared, n squared. Now, what I do now is I look for patterns where I have cancellations. So you can see here that this term and this term are the same. This one is positive, this one is negative. So this term cancels with this term. Likewise, this one and this one. If I were to do r equals 4, this term would cancel with the next one down here. And so on through the series. And that means that when I get to the bottom end, you can see that these two cancel. And this one would have cancelled with a term above. So that one also cancels. That means that I am left with this term here and this term here, which do not cancel. So the series gives me this term here, which is 0, plus this term here, n squared, n plus 1 all squared. Hence, we have, let's just simplify that to n squared, n plus 1 all squared. So that means that for 4 r cubed from r equals 1 to n, I have an answer of n squared, n plus 1 all squared. Now, the question that I was asked at the top of the page was just for the summation of r cubed. So I need to adjust my answer that I have at the moment to be the summation of r cubed between r equals 1 and n. And I'm doing that by dividing through by the 4, which means that I have the result 1/4 of n squared, n plus 1 squared. Which is what I was asked to show. So you can therefore see that by having an expression with a difference in it, I'm able to use that in a summation by inspecting the terms of the series, spotting patterns for cancellation, which then allow me to simplify and come up with an answer for the finite series. So that's your introduction. One thing to notice, please, I have clearly laid out the terms on separate rows, and I've given enough terms so that I can see the pattern. By doing it going down the page, you'll see from my working that I was able to clearly put diagonal lines through and identify the terms that remained. If I hadn't spotted the pattern straight away, I could have added in r equals 4 and r equals n minus 1. Usually you would be required to show r equals 1, r equals 2, and then the 2 at the end of the summation as a minimum amount of working. Add in extra ones if you need to be able to see the answer. And then I would also leave the terms uncancelled because it allows you to see the pattern more clearly. So that's your introduction. The following videos will give you some more complex examples, such as fractions or possibly different values on the summation, which you need to be careful with.